Okay, this is going to be for the setup of your new notebook for my class. On the very first page, you're going to need a table of contents. So I already wrote table of contents on the top, and you're going to write the topic number on the left-hand side. So the first one we're going to start off with is topic number 1. And the first topic we're going to be covering is naming lines, segments, rays, and angles. So we're going to write naming lines, segments, rays, and angles. All right, so that's going to be the topic name of the first um, pieces of notes that we're going to do. So once you're done with this first page, you're going to leave the rest of that page blank because we're going to be filling it out as we're doing more notes. You're also going to leave the back side of this blank just in case we have a lot of notes this semester, okay? So that means you're going to move on to the second page. On the second page, we're going to go ahead and start constructing three columns as part of your notes. Now, this first part, I accidentally named that wrong, so let me go ahead and name it correctly. Remember that we said that the title of this first one was going to be Naming Lines, Segments, um, Rays, and Angles. Um, you should have your name right here as well as the date. And for sure, we're calling this topic number 1. So this is going to be the first thing that we have. Notice that right now I have 3 columns going up and down. The first column is going to be for the term and the definition, second column for the diagram, third column for the notation and symbols. Now, because this is a video, I'm going to assume that you're going to go ahead and pause and write down everything that we have there so far. So go ahead and press pause right now on the video and jot everything down, set up your table. We're also going to have here uh, 2 more definitions. That's going to be 4 definitions total on that first page. It's going to look like this. Press pause at any point so you can jot all that down. And press pause on the back side of that paper, and you're going to have the rest of it that looks like this. So again, I'm going to assume that you already did this to cut the video down short, and we're just going to go ahead and get into it. So let's look at the first one. It says a point has no dimension and is a location in space. A point is usually represented by a small dot. The set of all points is called space. So what I'm going to do is I'm going to go ahead and highlight our vocabulary word, which is a point. And I'm going to go ahead and draw a point. Now I'm going to draw a point like what looks like to be on a sheet of paper, just so I can create some space like it's said on the definition. Okay, so here's my sheet of paper or my plane, and on that I'm just going to go ahead and jot a dot. This is my point. I'm going to go ahead and label that point point P. Now, as far as point P is concerned, this is the point that I referenced right here. So I'm going to highlight the point the same color so I know what I'm talking about. Okay. As far as how I would label that on your homework, you would call this point P. I know that sounds like, what the heck? Like that's exactly what I just said, but you're going to see the difference in a little bit. A point has no dimension. Okay. So we say that this is 0 dimensional. I'm going to go ahead right here and just label that this is 0D. There is no dimension to a point. Okay. All right, let's take a look at the next one. The next one says a line extends in one dimension and is the set of all points that extend in the opposite directions without end. It is usually represented by a straight line with 2 arrowheads. So the vocabulary word in this case is the word line. I'm going to highlight that in yellow. And I'm going to go ahead and draw a line. My line is going to look like this. And we're going to go ahead and label it with a couple of letters and a cursive L at the end. Now, lines are one dimensional. We say it has one dimension, okay? It's literally just doing this, okay? So that's the one dimension that it's traveling in. Um, and as far as the arrows, it's very important that we have these arrows because this is telling me that it's going on forever. And so I can't measure it, right? This thing goes infinitely long. And I know that because it has that arrow going to the right. Same thing to the left. This thing is infinitely long. So I can't measure it because if I try to measure it with a ruler, like let's say I put a ruler right here, it's not enough because this arrow is telling me to keep going. So I need another ruler over here. But that arrow is telling me to keep going. So I need another arrow ruler over here. And I just don't have enough rulers to go on forever. So we say that it's immeasurable. Okay. It's infinitely long. As far as how I'm going to label this, I'm going to label this a couple of different ways. One way I can label this is by calling it line AB. So I'm going to draw that it's a line, and then I'm going to write that it's AB on the bottom. Another way I can call this thing is by calling it line BA. So in this case, the order does not matter. I can call it line AB, I can call it line BA. The last thing I can call it is the thing that I haven't used yet, which is this cursive letter L. So I can literally just call it line L. So those are the three names, and they're all referencing the same thing. It's still line AB is the exact same thing as line BA is the exact same thing as line L. They're saying the exact same thing. So we're done with the first two vocabulary words. Let's go ahead and move on to the third one. The third one says a line segment is part of a line that consists of 2 points called endpoints and all the points between the endpoints. So what would that picture look like? That picture would look like something like this. And we're going to go ahead and put in some extra markings here as well. So the vocabulary word for this one is line segment. I'm going to go ahead and highlight that in yellow. What's different about this line segment? Well, number one, the main thing that I see is that there are no arrows. And so since there are no arrows on this definitely ends. It doesn't go on forever. Which means it's measurable. Like I can take a ruler and actually measure it. Now, just like a line segment is only one dimensional. It only follows this path right here. There is no other option. Okay, so we say that it's one dimensional. The other thing is that it ends. And so these things right here are what they described as endpoints. This is an endpoint right here. Point B is an endpoint because that's where the segment ends. That means point A is also an endpoint because that's what, notice that I highlighted that in a different color. We call this color coding. So because these endpoints I highlighted in green, and that means I know on my picture anywhere I see something that's green, it's considered to be the endpoints. Okay. Um, how do I write this using symbols? Well, using symbols, you would write this like this: line segment AB. How is this different than what we did above? Well, notice that the ones above have arrows on it. The ones down here do not have arrows on it because this is telling me that this segment ends at B and it ends at A. Okay, so whenever there's no arrows there, that means that this thing stops at some point. So I know that I can actually measure it because it's not going to infinity. Since I can call it line segment AB, then that means I can also call it line segment BA. That means in this case, order doesn't matter. And then the last thing I can say is that line segment AB is equal to 5 centimeters. Now, this is something that's always confused me as a child when I was doing geometry. I'm like, why didn't they put the line segment there? Like, what I'm saying is, how come on this statement they didn't write that little line up there? Well, notice that they're saying that line segment AB is 5 centimeters long. If it's 5 centimeters long, that means this segment ends. It's not going on to infinity. So there's got to be a spot where it ended so that I can measure it on both sides. In essence, what that's saying is I don't have to tell you it's a line segment because you should already know it's a line segment because I was able to measure it. It didn't go on to infinity. Okay. So it's kind of like a shortcut for us mathematicians. I don't have to write the line segment on top because since it's 5 centimeters, for sure it ends on both sides. Okay. All right. And then the last vocabulary word on that first page is array. Array is part of a line that consists of one endpoint called an initial point and all points on one side of that initial point. So what does that look like in the picture? In the picture, it's going to look like, we're going to show you a couple pictures. So I'm going to go ahead and write example 1. And I'm going to go ahead and draw an array that's going like this. And we're going to go ahead and include these points on that array. And then I'm going to show you another array that looks like this. This is going to be example 2. It's going to look very similar with just a couple of adjustments. All right. So vocabulary word. The vocabulary word for this one is array. So I'm going to go ahead and highlight that in yellow. Array is part of a line that consists of an endpoint called an initial point and all points on one side of the initial point. So check this out. On this one, this is considered an endpoint because if you notice, the dots are getting really, really close to A, and once it gets to A, it stops. So it's considered an endpoint. Point B is not an endpoint because when I start approaching B, I see B, but it keeps going. So B is not an endpoint, right? Like you're able to go right through B. So A is an endpoint, B is not an endpoint. Now it says that an endpoint on array is called an initial point. So if you have an endpoint on array, then we consider that to be an initial point. That means I'm going to go ahead and highlight that word right here. This is another vocabulary word that's kind of embedded. I have an initial point on example 1 at point A because it's an endpoint. B is not an endpoint. Let's look at example 2. On example 2, A is not an endpoint because as I approach A, I see it and I keep going right through. And that's the same thing going in the opposite direction. As I approach A, I see it and I go right through. So A is definitely not an endpoint. However, B, as I approach B, I see it and it stops. So this is an endpoint, and as we mentioned, if it's an endpoint on array, then we also call it an initial point. That means I can highlight letter B because it is considered an initial point. That's weird that we call it an endpoint and an initial point for array, but it makes sense once we start showing you in the next couple of seconds. So as far as symbols are concerned, how would I write this first one right here? Okay. So for example 1, I want you to notice that the ray starts at point A. It starts here, and then this ray starts going through B and goes on forever this way. So my initial point is at A. That's why we call it an initial point because that's where the ray started. And then it went through B. So I'm going to say that this ray started at A and went through B. Now, for example number 2, this is where the order matters. We're going to follow the exact same format. If I want to talk about this ray, I need to talk about where does the ray start and where does it go through. So it started right here. My initial point is at B. This is where my ray started, and then it went in the direction of A and went through it. So when you write this one, you're going to write using the same format. You're going to write ray. This ray started at B and went through A. The order matters. You always have to start with your initial point when you're writing this stuff and then tell me what it's going through. So we're going to go ahead and jot down a little note right here. Always write the initial point first. Just like before, these rays are one-dimensional because they can either go anywhere on that one line. Okay, so we're going to say that this is also one-dimensional. All right, we got 2 more examples and we're going to be done with this. Opposite rays are two collinear rays extending in opposite directions from the same initial point. Yeah, that sounds like a very complicated thing, but it's not too bad once you understand what it's saying. So let's see, opposite rays. We're going to go ahead and draw what looks to be a straight line. And on that line, I'm going to go ahead and put 3 points. Okay. So opposite rays is our vocabulary word. I'm going to go ahead and highlight that. Are two collinear rays. We haven't talked about what collinear means, but it means that it's got to be on the exact same line. Okay. Two collinear rays extending in opposite directions from the same initial point. So here's what I need you to do. I need you to take the next 10 seconds and try to see two different rays going in opposite directions, but that they're starting in the same spot. Again, I want you to try to picture in your mind, be creative, two rays in this picture. See if you can see two rays that are starting in the same spot but going in complete opposite directions. Now, if you're looking at what I'm looking at, I would say it's starting at point B. And from point B, one of the rays starts at B and goes up and to the left. There's one of the rays. And the other ray also starts at point B, but it goes down to the right. These two rays are considered opposite rays. They're considered opposite rays because they both start at the same point. They have the same initial point. In fact, I'm going to go ahead and highlight that word. So my initial point is B. And then from B, the first ray goes to the up and to the left. The other way goes down and to the right. Now, the reason why they're opposite rays is because both of those rays land on the exact same line. Like I can put a ruler underneath right here and be like, yep, that is the exact same line. I did not need two different lines in order to stack those two rays. They're on the same line, but they're going in opposite directions. Okay, so let's talk about this first ray. This first ray that I saw, we said it started at point B and it went towards A. So if I'm going to describe this ray, the first one, I would say ray BA. There's my first ray. And ray. The second ray started at B and it went in the direction of C. So I'm going to call it ray BC. So ray BA and ray BC are in fact opposite rays. Opposite rays, we say, are also one-dimensional because, again, they're only going on that one line. They're not going anywhere else, okay? All right, we got one more and we'll be done. An angle is formed by two rays with the same endpoint. The rays are sides of the angle and the shared endpoint is the vertex of the angle. Again, a lot of vocabulary there, but let's just show you what they're talking about. So I'm going to go ahead and draw an angle. On this angle, I'm going to start here. And one ray is going to go this way, one ray is going to go that way, and I'm going to label the heck out of this thing. So let's see, this is going to be point C, this is going to be point D, this is going to be point E. Vocabulary word for this one is an angle. It says an angle is formed by two rays. I definitely see two rays right there, and they do share the same endpoint. The endpoint would be right here. They share the same endpoint. It says the rays are sides of the angles and the shared endpoint is the vertex of the angle. So because this is the endpoint of this angle and it shares both rays, then we say that that endpoint right here is the vertex. So I'm going to go ahead and there's another sneaky vocabulary word right there. That vertex is that point C because it's the shared point between the two rays. It's the shared endpoint between the two rays. Okay, so a couple of things before we move on to, I forgot to write down one more thing. Let me go ahead and sneak in. We need a number one right here, okay? All right. The first thing I want to do is look at those two rays. Hopefully, you see two rays. The first question I want to ask you is, are those opposite rays? Remember that opposite rays are two collinear rays extending from opposite directions from the same initial point. So I definitely see two rays. Now the question is, are they going in opposite directions? And are they collinear? So these are in fact not opposite rays. And the really easy way of thinking of why are these not opposite rays? They're not going in the same direction. Again, it doesn't say that opposite rays don't go in the same direction. They say that they go in opposite directions and that they are collinear. So if I were to try to stick a ruler under this one, that wouldn't take care of both of these rays, right? Because it's not made up of one line. In fact, it's made up of another line. I would have to get a different ruler to kind of line it up here. That's not the same case as with this one, where I just needed one ruler for both of these rays going to the left and to the right. Okay, so it has to be on the same line and they got to be going in opposite directions. So even though these are not going in the same direction, they're not opposite rays because they're actually part of two different lines, this line and this line. Okay. So hopefully that makes sense why these two are not opposite rays. How are we going to label these things? Well, we can label them a few ways. One of the ways I like to say is like the tracing method or the pointer method. We're going to trace that angle. We're going to draw it without lifting a pencil. And if I'm going to draw it, then I would probably start like up here and I would go D, C, E. Again, I would start up here and I would go through D and then through C and then through E. So I'm going to call this angle DCE. I can draw that angle starting from a different spot. So if I actually started from the bottom, then I can draw it and go angle ECD. That's another way I can call this thing. I can call it angle ECD. I cannot call it angle CDE. Look, if I tried to do CDE, that means I would start at C, D, E, and now my picture is different, right? I'm not tracing the angle that I had before. All of a sudden, I'm coming up with this new line over here that wasn't there. So I can either go this way. Oops, that's not what I meant to do. I can either go this way, DCE, or I can go the other way, ECD. But I can't like start at C and call it like CED because now I'm drawing some other angle. Okay, so that takes care of two of them. We got two more things. We can also call it by the vertex if it's the only angle that has that vertex. So I can just call this angle C. And the last thing I can call it is whatever number they use here. Now, this is a labeling number. This is not a measuring number. What I mean by that is this doesn't say 1 degree. It's not measuring how open it is. It's just calling it angle 1. So that's exactly what we're going to call it. We're going to call this angle 1. Last thing on this one, this is two-dimensional because there's not just one line that you're following. You can actually follow a different line. So you'd have to go not only on this way, but a different method as well. So we're going to call this two-dimensional. You can't cover it with just one line. You would need a separate line going in a different direction. So angles are two-dimensional for the most part. There are certain angles that are one-dimensional. All right, those are all the notes that I have for today. If you have any questions, feel free to let me know.